Galileo is the guy who first formulated the idea of relative velocity, or at least he's credited with it. You never know the way history is. And what is meant by that is that velocity, talking about the velocity something has, only makes sense when it's relative to something else. If I have a car, and I say this car is going at 5 meters per second, well, what I'm really saying is that it's going at 5 meters per second relative to the ground. And unless it's specified, generally speaking, when we give a velocity or a speed, we are talking about how fast something is going relative to the Earth. But the Earth isn't an absolute reference point, right? The Earth rotates, the Earth is moving through space, and so you can't really say the Earth is at rest. If we're doing things on the surface of the Earth, it works out pretty well to assume that the Earth is at rest. But the Earth is moving, and this car would be moving at 5 meters per second relative to the Earth. Let's say we have another car, and let's say that car, we'll say this car is going at 15 meters per second relative to the ground as well. Now, obviously, this car is going faster than this car, and you can also clearly tell that this car, we'll call this car A, we'll call this car B, and say that car B is going 10 meters per second. Velocity of B is 10 meters per second greater than the velocity of car A. So another way of saying that is to say that car B is traveling at 10 meters per second relative to car A. And that's what relative velocity means, that you can think of it as being how much faster something is going than something else, or you can think of it as if car A was deemed to be at rest, how fast would car B be traveling? And the way we say this, the way we denote this is that we say velocity of B relative to A. So the first one is the speed, whatever we're finding the speed of, and the second one is the reference frame. So velocity of B relative to A is 10 meters per second. So if we consider A to be at rest, B is going at 10 meters per second, or you could say B is going 10 meters per second faster than car A. Okay. In like manner, we could go the other direction. We could say the velocity of A relative to B. Well, B is gaining 10 meters every second on car A, which means that A is falling behind 10 meters every second behind car B. And so A relative to B is at minus 10 meters per second. This is one of our rules. We'll say this is rule number 1. It doesn't really matter. But the velocity of A relative to B is always the opposite of the velocity of B relative to A. Okay? Now, what did we do to figure out that they were going at 10? Well, we just subtracted them. So there are a couple ways you can do this. You can think of it in terms of rules, or you can think of it in terms of reference frames. I'm going to talk about the rules first, and then I'll talk about reference frames. There are two different ways of thinking about it. Some people find one easier, some people find another easier. So we'll say rule number 2. So this 5 meters per second, this was the velocity of car A relative to the ground. VAG, velocity of car A relative to the ground, was plus 5 meters per second. Velocity of B relative to the ground was plus 15 meters per second. So what we did was we took velocity of B relative to something else. Often it's the ground, but it doesn't have to be. It could be anything. And the velocity of A relative to, in this case, the ground, but as long as it's relative to the same thing, it doesn't matter. you can simply subtract them to get the velocity of b relative to a. This is kind of another rule. If you have velocity of b relative to something, velocity of a relative to something, you can subtract to get the velocity of b relative to a. Okay. And then in similar manner, kind of combining rule number 1 and rule number 2, sometimes the velocities can add. So we know that velocity of a relative to b is equal to minus velocity of b relative to a. So if we have velocity of b relative to something and velocity of that thing relative to a, well, we know that velocity of a relative to c, velocity of c relative to a, these two are opposites. So this just becomes plus. So you get the velocity of b relative to a. So these are kind of, if you just want to memorize something and apply it, that's the way to go. Another way of saying these same rules, this is not the other way of thinking about it yet, but this is another way of using the same rules. So if they're going in the same direction, you subtract. So a and b were going in the same direction, but we subtracted to find their velocity relative to each other. If they're going in opposite directions, you add. So for example, if say we have car A relative to the ground is going at minus 6 meters per second, velocity of car B relative to the ground is going at positive 5 meters per second. Well, B is going this way, A is going this way, so the space between them is growing at a rate that's equal to the sum of their velocities. So 5 plus 6, the velocity of B relative to A, is 11 meters per second. Okay, so that's and when I say subtract and add, I'm talking about absolute values. Right. Now there's a second way of thinking about it, and that is in terms of reference frames. Reference